As far as the eye can see, rocks and dust are everywhere. Even deserts, the driest places on Earth, are wetter than here. But Mars wasn't always what we see now. If you were studying the solar system millions of years ago, you might be surprised at the similarity between Mars and Earth. Because the surface of Mars was covered with seas just like the world in the past. The reason we can say this is because of the structure of the rocks on the Mars surface. We know that these rocks, consisting of clay and limestone, absolutely need liquid water in order to form. Because it is formed as a result of the hardening of the minerals in the clay soil by combining with water. There are examples of this almost everywhere in the world. A second piece of evidence that there used to be water on Mars is the pebbles found on the Mars surface. The sharp stones in the waters flowing in the rivers roll in the current. And during this rolling, the stones that hit each other rasp their sharp surfaces over time. And in this way, pebbles are formed. And then these pebbles pile up on top of each other and smaller grains of sand begin to fill in between them. With the effect of water, these stones harden over time. And sedimentary rocks are formed. We often come across this in the Earth. And yes, the fact that these sedimentary rocks are found on Mars as well as on Earth tells us something. There used to be water on Mars. If this was not satisfactory, there is clearer evidence that there was water on Mars. Take the Gale crater, imaged by a satellite orbiting Mars. This photo is seen as evidence of the presence of frozen water on Mars. Another satellite image that can be shown as evidence is the crater called Korolyov crater. It is clearly seen that the interior is completely covered with ice. And despite its small appearance, the Korolyov crater is 80 kilometers in diameter and 2 kilometers in depth. Imagine how big the meteor hit here. We've all heard that Mars is called the red planet. Mars gains this redness from the dust on its surface. This dust is nothing but the rust formed as a result of the mixing of iron and oxygen. The surface of Mars contains rusted iron dust. That's why we see the Martian surface in red. Of course, when you look closely, other colors formed by the rock layers are also visible, unlike those seen from space. Let's get to the atmosphere. When we look up in the Earth, we see a chirping light blue color. The reason the sky looks blue is because of the refraction of light. When the sun's rays enter the atmosphere, they are scattered by hitting the gas molecules and dust particles in the atmosphere. The daylight is composed of many different wavelengths. The shortest wavelengths of blue rays are immediately scattered by small particles in the upper atmosphere. But red light, which has the largest wavelength, has to hit larger particles to scatter. When the sky is clear, blue light is the most scattered light compared to other lights. This is why the sky appears blue. But the Martian atmosphere is not like ours. That's why blue light is not scattered into the atmosphere like on Earth. On the contrary, red dust clouds scattered in the air paint the Martian atmosphere red. There is an interesting situation regarding the color of the sky on Mars. Just as the sky turns red when the sun goes down on Earth, the sky turns blue for a short time because the angle of incidence of the sun's rays decreases when the sun is shining on Mars. Most space rocks smaller than a football field will break apart in Earth's atmosphere. Traveling at tens of thousands of miles per hour, the object disintegrates as pressure exceeds the strength of the object, resulting a bright flare. Typically less than 5% of the original object will ever make it down to the ground. These meteorites, pieces of meteors that are found, typically range between the size of a pebble and a fist. Many meteorites, large and small, that enter the Earth's atmosphere, burn and disintegrate before they can fall to the Earth's surface under the influence of the atmosphere. On Mars, on the other hand, there is no such protective atmosphere layer. For this reason, meteorites caught in the gravitational effect of Mars collide with the Martian surface without encountering any resistance. Since Mars does not have an ozone layer, the rays from the sun can reach the surface directly. And this is causing the surface temperature of Mars to rise very high. This is why the water on the Martian surface is thought to have disappeared from the surface a long time ago. And everywhere except the poles of Mars is extremely dry. Due to the lack of humidity, the temperature difference between day and night reaches 100 degrees Celsius. Air pressure on Mars is also very low. The air pressure on the surface of Mars is the same as the air pressure 35 kilometers above the Earth. Also, the Martian atmosphere consists of 96% carbon dioxide. Therefore, it is currently impossible to breathe on the surface of Mars. Situations like these will create a great challenge for people who will go to Mars to live. Exploration tools that allow us to obtain information about Mars are also looking for life or remains of life on Mars. Energy sources, water and organic molecules are necessary for life to occur. There is sun rays as an energy source on Mars, just like on Earth. As we mentioned at the beginning of the video, we also know that there was water on the surface of Mars before. That's why Mars probes are primarily looking for organic molecules, such as proteins, on the Martian surface. If these proteins are found, it could prove that there was life on Mars before. For this reason, it is of great importance that you examine the rocks where the water used to be. That's why Mars probes take rock samples whenever possible. Thanks to the small drill in the robotic arm, samples are taken from the rocks and chemically examined.